We're covering two things today. Determination of unit digit or determination of last two digit. Okay. For any power. Okay. So the underlying concept, the first concept is that if any two number is getting multiplied, like 2159 into 3256, the last digit of this multiplication, the last digit of this multiplication will be same as last digit of 9 into 6. How do we prove that? We can divide the number into 2150 plus 9 into 3250 plus 6. When I'll multiply this, you can just see that all the term, this particular multiplication will have four terms. 2150 into 3250 3250 plus 2150 into 6, 9 into 3250 plus 9 into 6. So what you can see here is that just because this two zeros are here, this multiplication will have 0 as last digit. This will also have 0 at last digit. This will also have 0 at last digit. So the multiplication of this will get its unit digit from this multiplication. So the last digit will be 4. Similarly, you can generalize this statement for two digits also, that if 2159 into 3256, we are multiplying these two, the last two digit of this multiplication will be same as the last digit of 59 into 56. So to prove this, you can again think like this. We will divide the number into 2100 into 5 plus 59, 3200 plus 56. And then if we'll multiply this, all the three multiplications, all these three multiplication will have 0, 00 in its last, and this will give you the last two digit of this multiplication. So 59 into 56, if we multiply this, whatever the last two digit is here, we'll get the last two digit at this place. Okay. So this is a basic concept, a basic understanding of determining last two digit or unit digit. So now let's say if a number ends with 2, like somebody is asking 2132 to the power 81, what will be the unit digit of this? So what we can see here, or what we can actually conclude from the previous concept, that this particular term or number is being multiplied by itself 81 times. So the last digit of this will be same as last digit of 2 to the power 81, because every time 2 will get multiplied and it will get multiplied with other 2, and it will give you the last digit of the multiplication. So the problem has reduced to this. So these three terms doesn't matter. The last two digit of this power and last two digit of this power will be same. Now, if 2 to the power 81 is there, if we'll start multiplying or checking the powers of 2 and what are the unit digit at different power, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8, 2 to the power 4 will be 6. The last digit of 2 to the power will be 6. I'm not writing here 16 because I don't have to do anything with that. Now 2 to the power 5 is 2 again. So basically what are you getting? You are getting a cycle of 2, 4, 8, 6. And in this cycle, every fourth power of 2, I'm explaining it for 2 and you can do it for all other digits. Every fourth power of 2 will give unit digit of 6. No, sometimes what people do mistake as they take the every fifth power will be 2. No, it's not. Uh, every fourth power will be 6 and then next power will be 2 and the next power will have 4, next power will have 8 and 6 so on. So in order to determine what will be the unit digit of 2 to the power 81 and 2 to the power 81, I'll be checking that whether 81 is getting divided by 4. What will happen when 81 will get divided by 4? We can see that 80 gets divided by 4 and we have one more power to it. Like this can be reduced to 2 to the power 80 into 2. So this 80th power is like multiple of 4. So this will give you 6 and the next power next will be 2. So the seventh one, like fourth, fifth power, not fifth power, 81th power will be 80 plus 1. 80th power will have 6 and then next power will have 2. And similarly, if 2 to the power 82 would have been there, it would have given you 4 as unit digit. 2 to the power 83, 8. Then 2 to the power 84, again it is divisible by 4, 84, then it will give you 6 again. So this is how you get the pattern of unit digit for any power of a number. So like 2, you can develop the cyclicity of all the other digits. So we do have 10 digits as an option for our last digit. So we will have cyclicity of all those 10 digits by checking. So I'll write the cyclicity of all. If any number has or is being ended with 0, it will always give you 0, all the powers. If 1 is at the unit digit, it will always again give you 1. If 2 is at unit digit, it will give you 2, 4, 6, 8, sorry, 2, 4, 8, 6, and then 2. This will be the cyclicity. If 3 is at unit digit, 3, 9, 7, 1. 3 into 3, 9, 9 into 3, 27, 77, 27 into 3, 61. Sorry, 81. So 1. Then again you will get 3. So 3 also has a cyclicity of 4. If you have 4 at unit digit, 4, 6, 4, 6, it has just cyclicity of 2. If you have 5 in the last, you will get 5 always. If you have 6 in the last, you'll always get 6. If you have 7 at the last, in the last of the number, you will have 7, 9, 3, 1, and then 7 again. If 8 is there, 8, 4, 2, 6, and then again 8. If 9 is there, 9, 1, 9, 1, it will have cyclicity of 2. Okay. So all the 10 digit I have discussed here. So now you can actually, if someone is asking you that what will be the unit digit of 29 to the power 8 into 32 to the power 4 into 26 to the power 9. So Here we will get the unit digit of this power, then we will have unit digit of this, and then finally we'll multiply those unit digits. So I can see that 9 has a cyclicity of 2. So every 2 second power will have 1. So this will give you 1. Either here the 2 is at unit digit. So 2 has a cyclicity of 4. So every fourth power will have 6. So this will give you 6. Again, 6 has a cyclicity of 1 only. So any power of 26 will give you 6 at the unit digit. And finally, you will get 6 at unit digit. This is how we calculate unit digit for any multiplication or other thing. So now the question which was there, you had x to the power 6 plus y to the power 6. You could have calculated what will be the unit digit here. Okay, you don't have to multiply 6 times. Okay, Nakshat?
Yes, sir.
Okay. So now let's go for two digit square, sorry, finding two digits. So it I'll give you a very interesting concept and it will help you a lot. First, we'll write the squares of all the numbers till 25. So please, you can also speak the squares 0, 1. Have I completed this in any chapter and before in any of our class? I'm teaching this in first time, no? Hello.
Yes, sir.
Okay, so let me write it. 6 square will be 36. बोलते चलो तुम अभी 4 7 square will be 41, 49. 8 square will be 64. 9 square will be 81. 10 square. This is a very interesting concept. That's why I'm writing it. 169, 196, 225, 289. No, sorry, 256. 17 square will have 289. 18 square will have 324. 19 square will have 361. 20 square will be having 400. 21, 441. 22 square 484. 23 square 529. 24 square 576. 25 square will have 625. So now with this table, we'll be learning two things. First, that every continuous square, the continuous number, the squares of the continuous number will have a difference of some of those numbers only. I mean, if you want to go from 1 square to 2 square, you just have to add 1 plus 2 into it. You will reach to 4. Then if you want to go 4 to 9, 2 square to 3 square, you just need to add 2 plus 3 into it. You will reach 9. So by this way, let's say 15 square is 225. If I'll add 15 plus 16 into it, which will give you 256. And this will be the square of 16. So it's not magic. It's just simple algebra. If I do 16 square minus 15 square, what I'll get? It is 16 plus 15 and 16 minus 15. 16 minus 15 is 1. So ultimately, the difference of these two square will be addition of these two numbers. Okay. So this is the one thing which I wanted to tell you from the table. Second, one of the short tricks that everybody knows, that if any number has 5 in its last, like 25, if you want to square of 25, you just need to write 25 in the last, and you will multiply 2 into 3, just one number greater than the number as it, uh, which is matlab like which is matlab 5 is being followed by your which comes before 5. So it will 2 into 3. So this will be the square of 25. Similarly, if you want to calculate the square of 75, it will give you 25 and 7 into 8. Okay, 56. Similarly, if you want to calculate the square of 125, you just need to write 25 and then 12 into 13. So 12 into 13, what will be 12 into 13? 156. So this is how you can calculate the square, and this will help you in finding the square root of such numbers also. Like if somebody is asking that what will be the square root of 4225, if it has any integer root, it will be in that format only. This 5 denotes 25 is for 5, and this is 6 into 7 consecutive numbers. So the root of 4225 will be 65. Okay. So this was the second thing. Although these two things are not that important, just you can get help in finding new squares or the squares ahead, and also it will help you in calculation related to any number which has 5 at its unit digit. Now let's go back to the table, and what I wanted to tell you was, and we were trying to find the last two digit of all the squares or powers. So I have written all the squares till 25, and I'll show you now that any square of any number, like any number, any natural number, if you take any natural number, if you square that number, the last two digit that you will get will be one of these 25 last two digits only. Like let's go for the next number only. Like if 25 square I have already written here. If I want to calculate or find what will come as last two digit when we square 26, and I'm not squaring it, I'm not finding the real value of, of 26 square. I'm just trying to fetch the last two digit of this square. So in order to do that, I'll represent the same number 26 as 50 minus 24. And now through algebra, we know that a minus b square is 50 square minus 2 into 50 into 24 plus 24 square. So now what you can see here is that this square will give you 20 in its end. This multiplication will also give you 20 on its end. So the last two digit of this square will be coming from last two digit of this square. I mean, the last two digit of 24 square is same as last two digit of 26 square. Similarly, if I'll take a number 74 and I square it, we can write the same number as 50 plus 24. And what I'll get here is 50 square plus 2 into 50 into 24 plus 24 square. So what I'll be getting here as last two digits, 00. Here also 00. So what you can see that even the 74 square will have the same last digit as 24 square. So these two last digit will actually make the last two digit of 74 square. Similarly, I can take one more number, which is 86, not 86, 76, sorry, 76 square. And we can convert 76 into 100 minus 24 square. And then again, you, by the same logic, you can tell that the last two digit of 76 square will be same as last two digit of 24 square. So how are we getting this pattern? So the last two digit of 24 square is being followed or being repeated four times. One, 24 itself. Second, 50 minus 24, which is 26 square, which is 50 minus 24. Next, 50 plus 24, which is 74 square. Next, 100 minus 24, which is 86 square. So similarly, all the numbers before 24 also, if you want to check it for 18 square, the last two digit of 18 square will be same as or will be same for 32 square, 68 square, and 82 square. How am I getting it? It is 50 minus 18. It is 50 plus 18.
सर
Yes.
सर जैसे आपने 100 - 24 लिया, अभी 100 - 18 लिया, तो 100 + 18 का भी तो सेम ही होगा.
एग्जैक्टली exactly. तो वो इसी तरह से ना एवरी 100 विल इन एवरी 100 इट विल हैव फोर टाइम. बिल्कुल बिल्कुल सही कह रहे हो तुम. यू आर टेलिंग एब्सोल्युटली राइट. So if you want to calculate 326, last two digit of 326 square, so you'll be getting it what? 350 minus 24. So ultimately it will give you the last two digit of 24 square only. So that's what I was trying to tell you. Every number, every natural number will have its last two digit, the square of any natural number will have its last two digit from this set only, which I have drawn or made the table above. No natural number will have any square which doesn't have last two digit from this set. So in 100, in one complete 100, 1 to 100, all these last two digit will be repeated for four times. Okay. So let's go back to the where I was checking all the numbers. So the 18 square, the last two digits of 18 square will be repeated four times in 100. Then again it will be 118, 132, 168. Because one doesn't matter, because last two digit will be coming from last two digit only. So like I already explained you that other numbers, other than the last two digit doesn't actually matters for it. So all the number can be, the last two digit of any number can be found, square of any number can be found if you remember or if you can calculate the last two digit of square of these 25 numbers. So if I'll ask you, let me ask you a few question with this. If you want to calculate the last two digit of 5669, what will be it? क्या होगा बताओ?
61.
किसका किसका फॉलो करेगा? 69 है, which is 50 plus 19. and 50 plus 19, so 19 का square का last two digit is 61. So this will be the last two digit of this square. Similarly, let me ask you another one. Is everyone getting this?
Yes, sir.
Very good. So similarly, if somebody is asking that 21539, what will be the last two digit of this square? You know it. This doesn't matter. So actually, the last two digit of 39
21.
and
21.
21. So what are you doing here is 50 minus 11.
11.
So the square, the 11 square will have 21. So the last two digit of. So this is how you can calculate the last two digit of any square. Okay. Now there is another application of the same, which actually makes the calculation easy. जैसे कि कभी कभी, although you will not require to do that or find the square root of the numbers in even in your cat paper, but let me give you this. There is a square 78961. So x square is 78961, and you need to find x. Basically, root under 78961. So how we can calculate the square root of this without using any square root calculation trick or formula? So I know this particular square, 100 square is 1 4 zeros. 200 square is 4 will have 4 zeros. 300 square will be this. So I can easily tell that the square root of this number will be between this. Now, with this 61, I can tell that the number can be either 219 or 231 or 269 or 281. You know? Because 61 comes as a last two digit for 19 square. Okay. So once you've got this, you can find the mid value, 250, square of 250, which is very easy, 62500. And this particular number is greater than 62500. So these two options got cancelled. So you have this and this. Now you can check for anyone, or if you don't want to check, you can just find the in between number. Here you have 20, 270, and 270 square will have a value of, or
72,900.
whatever. So this number is basically greater than this. But you can also find that this particular number is close to 90,000. So this will be the answer. So this is how you get some help in finding a square root of a number which actually has a square root. So ऐसा नहीं है कि कभी somebody is asking that what will be the square root of 77961. So you'll start calculating the square root. This will not have an integer square root. Okay. So only if you are sure that this particular number has an integer or square root, then only you can use the trick to uh, find the square root. Now let's come to the main target or main goal of our lesson was, which was finding the last two digit of any power of any number. So the first thing which I have already explained to you is that it doesn't matter what exists beyond the last two digit. Like if you want to calculate 359 square, like 33rd power of last two digit of this. So it will be same as last two digit of this. So the first thing that you have to realize that this actually doesn't matter. Okay. Now this particular power, how you can achieve this particular power by using squares only. Why? Because we know how to find the last two digit of any square. So to reach this 33, what I'll do, I will start squaring 59. So with every square, everybody knows that what happens with when we square it. Uh, how much power 59 has now? Anyone?
16.
16. Then we'll have a square again. Then how much power we do have now for the 59?
32.
32.
32.
And now if we'll do the another square, it will go 64. So we'll not do that. What I will do is multiply 59 after this. So this power is 1 actually. So this particular term has been converted into this. Now just see the smart thing that we'll be doing here. I know that 59 square will not be a two-digit number, but I just have to write the two-digit number because other digits will not be responsible for last two digit ahead. So 59 square with one power will give you 81. Why? 50 plus 9. 81 square, then again we'll square 81, it will give you 61. If we will square again, it will give you 21. And why? It was 100 minus 19, it was 50 plus 11, it was 50 plus 11. Now, if we'll square 21, it is under 25 only, and we all know it is 41. And if we'll square again, it will give you again 81. So all these power will make the last two digit as 81. And then we have 59 also. So we'll just multiply 81 into 59 to get the last two digit of this power. Did everyone get
सर
that?
ये कैसे आया? ये 81 पहले कैसे आया?
देखो 9 59 है ना.
Yes.
59 is what? 50 plus 9.
अच्छा तो 9 9
हाँ, 9 9 81. So this is how we can get. Now, if you have larger power, the more than 33, you can just give me any number or any power. I'll tell you how it can be done. Chalo, anyone can experiment with any number. Tell me. बोलो भाई, कोई भी बोलो.
So 169 raised to the power 169.
1 raised to power 169. And actually they ask question like this also कि आपको लगे कि कुछ ट्रिक होगा या कोई फॉर्मूला होगा, ऐसा कुछ नहीं है, ये वही काम है. So what do you know that it can be converted into 69 to the power 169. And if we'll write the power of 69, then I can write till what number? Batao. Till what? One power will one square will have 2, 2, 4, 8, 16, 32, 64, 128. है ना? So I have already completed 128. Now if I'll have a square again, it will be 256. Then I'll have a multiplication term and we'll have 69 powers again 5 times. So 128 plus 32. It will give you what? 160. Okay. Then I will have 69 to the power 3 times. Like it will be 8 and then 69 also. So basically I converted the entire multiplication as I'll write it here. 69 to the power 128 into 69 to the power 32 into 69 to the power 8 into 69. Is it fine? What it is? 69 to the power 169. Hmm? Now you just have to find the calculate this one. Rest all you will get through this only. So this power will give you what? 61. This will give you 21. This will give you 41. This will give you 81. This will give you 61. This will give you again 21. And this will give you 41. So now it weighs 41 into. Now here you have 5 times square. So I'll just take 1, 2, 3, 4, 5. 61. You have 3 squares here. So I'll take 41 again. And in last, I'll have 69. So you can just reduce this 41 into 41 will again, it will be 81 and 61 into 69. Now you can multiply this and find the last 2 digits of this power. Is it fine?
Yes, sir.
So this is how we calculate.
सर ऐसा क्वेश्चन आ सकता है पेपर में?
आने को तो आ ही सकता है ना, ये कुछ नहीं है।
तो सर अगर सारे ऑप्शन के लास्ट के 2 डिजिट सेम ही हो तो फिर क्या करें?
वो लास्ट 2 डिजिट ही पूछ रहा है ना, तो ऑप्शन में लास्ट 2 डिजिट ही देगा। They
अच्छा
will not ask you what is the value of this power.
ओके सर वही पूछना था।
ठीक है। So now I'll give you a task. I have 50 factorial. Okay. Not 50 factorial, it will be too large for you. So I have 30 factorial. You have to find numbers of 0 in the last. I have already taught you about this. Numbers of 0 in the last class. 0 in last of this factorial. Second question is rightmost non-zero number. Non-zero digit, sorry. So like you, if you are getting a multiplication like 2, 6, 5, 2, 000. So the rightmost non-zero is this. Similarly, last 2 digits before zeros, like 52. This is. So you have to find out this also. Okay, this will be for homework. You can just write it down and Do it by yourself. We will be discussing it tomorrow. So in tomorrow's class, we will be doing APGP and probably reminders also. Okay.
Okay, sir.
सर मुझे एक क्वेश्चन पूछना था
पूछो।
एक